TAF-35 is another extinguishing robot. It's essentially a Caterpillar-tracked firefighting system with a turbine. It's produced by the Italian company ME Controls, and it operates in a simple but efficient manner. The turbine sprays a cloud of fine drops of water into the air, like a mist. Then, using a propeller and an airstream, the unit moves the cloud of water towards the fire. The water mist takes the heat away from the fire very quickly, reducing its temperature. In this mode, the TAF-35 consumes up to 1,500 liters of water every minute. There is a jet spray mode where the water consumption increases to 4,700 liters per minute. The water can also be replaced with foam if required. As other vehicles shown today, the TAF-35 is operated using a remote control, which makes it perfect for situations where it's too dangerous for people to enter a building, or when the area is difficult to reach and a standard fire engine can't be used to get there. The operating range is 300 meters.
These are excavators. But this one is different. No one is operating it. As our world continues to grow and evolve, so do our infrastructure needs.
Bridges are going to fall apart, dams are going to break, levees are going to be overwhelmed, and the reason that we're not doing that kind of work right now is just too expensive. But if we don't take care of them, then it's going to cost even more in the long run. Neglected or ignored by the technology industry for a long time.
The way they've done this is pretty clever. They actually don't make any construction equipment.
So what we develop is an AI guidance system that you can install on commercially available off-the-shelf equipment from Cat, Deere, Komatsu, any of the major manufacturers. And then we write the software that goes inside that system and interfaces with the machine so that it's able to navigate around the job site. And it's using stuff like GPS, cameras, LiDAR, radar in order to observe its environment. And then robotic equipment operators are able to load in plans or blueprints and then tell the machine exactly what they want it to do. And you set it up, you hit go, and you come back at the end of the day when the machine's done.
Imagine a future where one operator is managing 2, 5, or even 10 of these machines. Job sites that used to sit idle could now have robots working around the clock. A job that would have taken months before now takes weeks.
Is becoming more advanced every year. MVF-5 is a multi-purpose firefighting vehicle developed by the Croatian company Doc Ing. Its main feature is that it can be controlled remotely, which means the operator is safe at a distance of up to 1,500 meters. At the same time, the vehicle has an optimal size to get into hard-to-reach places. The engineers provided the MVF-5 with 2 tanks, one for
M2000IA. It is the strongest robotic arm in the world and can lift loads of up to 5,000 pounds. It is used to lift heavy loads such as vehicles or large machine parts. KUKA OmniMove. It is a robotic platform that is used to transport heavy loads such as trains or airplanes. It uses omnidirectional wheels that allow it to move in any direction, even in tight spaces. It can be controlled manually from anywhere or operate autonomously. It has great precision and can carry loads weighing up to 90 tons. At present, many of the leading vehicle manufacturing companies use these types of robots. Laser Snake. It is a laser cutting robot operations with small objects. It can be used in various sectors for handling food, pharmaceutical products, or other objects. The size of its arm can allow him to work in small environments and has a range of 31 inches.
Cleveland Clinic has a long history of advanced minimally invasive and robotic surgery, both in the United States and here in the Middle East. We've been doing these procedures for over 20 years.
Inside the patient with our head in a 3D console, so we get 10 times magnification and much better visualization, so we can see tiny little blood vessels and dissect things in a very precise manner.
And that fingertip movement allows the instruments inside the patient's chest cavity to move with levels of freedom and degrees of freedom that far exceeds my own hands. You are in a better situation than patients were 25 years ago.
With this machine, we don't need to stop the transmission of electricity. It can move on live lines. Here in Japan, we're using up to 500 kilovolts, but it could be inspecting. So, for example, if we stretch this manipulator all the way to one side, we end up lifting the pulleys in the other side. By lifting the pulleys, then we can do those acrobatic modes I was talking about, rotate them outside or use them to overcome obstacles and so on.